Hi everybody, I have updated the assignment instruction for assignment 6, so please get the updated instruction from Kura again. So in this updated document, I kind of detailize about the class you need to define in your assignment 6. So in general, we need to create Mandani fuzzy system, right? And also scanner fuzzy system and Komodo fuzzy system, because although most the contents are similar, but again, since the inferences and the construction are a little different, so we like to make them separately defined. We are not going to set up a families of fuzzy inference system. So remember that you need to create Mandani fuzzy system, scanner fuzzy system, and Komodo fuzzy system. Up to now, I think we have defined the Mandani fuzzy system, right? This is a Mandani fuzzy system. So basically, what a system, Mandani fuzzy system, is a list of if-then rule. Okay, so you need to define a constructor, ask the user to prepare this arrays of rule for you. So that is a mission, for the user interface. The user interface needs to correct all the rules defined by the user in order to create Mandani fuzzy inference system to do the inferences. Okay, so this is Mandani. And also, before assignment 6 we have create and define this if-then rule, right? So in that case, if-then rule is actually Mandani if-then rule. So a Mandani if-then rule has antecedent parts, right? It's a list of generic fuzzy set, and we also have a conclusion fuzzy set. That is the Mandani if-then rule. So this is the constructor, and then the inferences function we complete is that fuzzy in, fuzzy out inferences. But right now in assignment 6. We will loop through each crisp input value, and try to get defuzzified crisp output value, right? So we need to add a functionality to if-then rule. Then in the Mandani fuzzy system, we can aggregate all the result from all the rule in order to get the final output. So as the instruction indicated here, we were needed to add a function crispy in, fuzzy out inferences for the Mandani if-then rule. So back to here's this one is for fuzzy in, fuzzy out, right? Example fuzzy in, fuzzy out, right? So we will have similar function will be added to our if-then rule. So that should be fuzzy in, should be crispy in, fuzzy out inference. So what we are asking is a double array. So we call it condition. Okay, for if-then rule, it's very simple because I have antecedent parts and the conclusion fuzzy set. So I always report output should be a cut, either way, should be cut or scaled output fuzzy set. So probably it should be the case that we ask for whether it is cut or is a scale. So by default, we will ask the user supplies another information. So we ask for is cut. It's cut operate. So in here we can set default value. So its cut value is by default we set it to true, right? So later on, if the caller want to ask this rule, inference its result, the caller needs to pass either true or false. If it is true, then we return a car value. Otherwise, we return scaled. So let us modify the previous function we have, right? We have fuzzy in, fuzzy out, right? So if we add this new argument here, as you can see, we will return the result should be different, right? So we will say if is cut operator, then we return the firing strength cut the conclusion fuzzy set. Else we will return file strength times conclusion fuzzy set. So that is fuzzy out. So similarly, you need to carry out. You need to carry out the well. Eventually, again, we will have what we will have firing strengths, right? So the algorithm should be similar. So you need to do that by yourself. I'm not going to show the details. So I will let you finish this part. But remember that in fuzzy inferences, we use the condition fuzzy set. It is a fuzzy set intersect with the antecedent parts, and then this is the intersected fuzzy set, right? So we return the maximum degrees as the firing strength for this antecedent parts, and then we take the minimal value. So minimal value will be used to fire the cut operation or scale operation. So it's similar, but right now, since you have condition, in a CRISPR value. So what you need to do, actually, what you need is that you ask antecedent. Probably, for example, the J's antecedents get members degree. So that will be your firing strength, right? Conditions. J's, right? So you can directly use the get members function to get the firing strength for this antecedent part. So you need to finish that by yourself. Okay, so this function will be used in our Mandarin fuzzy system. So let's go back to Mandarin fuzzy system. In Mandarin fuzzy system, we provide interface function. We ask that should be crisping, crisp out, inference. So user will prepare its condition, right? And we will inference. We will ask all the rule inference its result. So in here, it's crisping. So you need to what? Look through all rules to get output fuzzy sets. Cut or scaled fuzzy set, right? And look through our rule and get output fuzzy set. Get united output fuzzy sets, right? That is your final output, and then return the fuzzified value. Okay, that's it. So this one will be used in your user interface, right? So we will call it in this button or another button if it is two-dimensional. So basically we will have this one is for three-dimensional. That is for two-dimensional input-output, right? So within this button, actually, we will have a condition, right? We have a CRISP condition right here, input 0 and 1. So we have 0, and then we ask them to identify the input system, CRISP in, CRISP out inferences. Then we put input there, so we will get a defined value, output back, plus. So this is just one reference, one instance reference, right? So we need to look through all the possible input combination and then get final result. So that is the identified inference system. So it's simple. Let us quickly come back here. This is our identified this system. So if you want to create a identified system, you need to prepare the array of if-then rule. Okay, and then in your button you will invoke this one. So actually, if you think about the detail, if you finish this one, if you finish the CRISP in, excuse me, if you, okay, it's fine. It's really closely related to this guy, right? So actually, you can put every code right here, and since it's returned a generic Gaussian for this set, so it will be very easy, right? So you need to do mutual code here, since it's CRISP in, CRISP out. Excuse me, CRISP in, fuzzy out, right? So that should be returned. Look through all the rules to get united output fuzzy set. Yes, that's it. And then you call it. This function, you call this function, right? Why not? You can call it. Right. So once you call it, you will get generic fuzzy set. I will call it conclusion. Conclusion fuzzy set. Well, I may not call it conclusion because that will be confused with the rules. I will call it resulted fuzzy set. CRISP in, fuzzy out. So you need to look through all the rules to get united output fuzzy set. Right? So pass that into it. And depending on the user specified type, it will be kind of switch type, right? Case. This differentiation type is defined by you, so invoke it. If it is COA, right? What should you return? Return what? Return resolve fuzzy set dot COA CRISP value. Right? Other cases, you can do that by yourself. There is VOA, right? We will return resulted fuzzy set VOA value. We have not implemented yet, right? So you need to do that. It's very simple. So each case will have maybe you just define this word here, default. So by default, it will return COA. Otherwise, you have another cases you need to default return other things. So we don't need to have this return statement here. So each case has been taken care of, so it's okay. So you need to finish this part. CRISP in, fuzzy out first, and then we will call it and get the final result of the fuzzy set. So depending on the user specified differentiation type, will return the CRISP value back to the user. Okay, this is some maintained fuzzy set. All right, so well, within here, you might invoke what? For example, for because right now we have a fixed array, right? So that is for int rule start from 0, rule smaller than all rules dot length. In C#, if it is an array, it's a one-dimensional array, and definitely you will have a property length indicated that how many element has been stored in this array. So you can use length property to know the size of that one-dimensional array quickly. So what you need to invoke is that what you might have. I'm not going to show you everything, right? So you basically you invoke the CRISPR-in fuzzy out inferences, right? So you simply pass conditions to this interface function or evident rule. So you need to assign the result back to here somehow, and then loop through all the rule and then aggregate the output for this output for this. So basically, I think we needed to get the so we need to subtract, but it's cut operator, right? So we need to know that. So probably in your Mandana system, you might set up a property public. That should be a bool. I might say use cut operator to inference. Anyway, probably you can make it short. Use cut operator, right? So we will set the user set and get, and we also set up initial value shall be true. By the way, it's true. So user can once user construct a Mandana for the inference system, they can set whether the final conclusion for the is a cut fuzzy set or a scaled fuzzy set. So right here. So during the inference, you need to pass this setting to this function to let the rule return either a cut fuzzy set or a scaled fuzzy set back to you. So you need to eventually unite them all them together. So that is your job. You need to complete that. So for Mandana system, it is clear that we define a Mandana fuzzy set system. We carefully specify the content of a Mandana fuzzy system should be a set of evident rule. I said. And we need to let the user specify whether the cut operator is used for inferences or not. And in addition to this flag, we also needed to let the user specify the defuzzification type, right? So maybe this one, well, in this case, we kind of let the user determine it. We did not set the defuzzification type as a property or Mandana fuzzy system. So probably maybe we like to do that. So we also provide public defuzzification type. Called mode, right? So set get initialize it with what? With COA. Okay, so since right now we have this property assigned, so in that case, in this function, I think we can just leave it out. We don't need to use it. But instead, we will set up the switch should be defuzzification mode specified by the user. So we put this flag and the defuzzification type in the Mandana fuzzy system, and then make it this property public, so user can arbitrarily set it before invoke this CRISPR inferences. Okay, that's it. So the similar structure you should carry on. I mean, for the scanner if then rule. This is scanner if then rule, right? So we kind of prepare a public static function, static get output value there. And for a scalar if-then rule, we have antecedent paths as a list of fuzzy set, right? And our conclusion should be index, just equation index. That's it. So conclusion equation ID. So later on we can invoke this static function to get the output value. And here, for a scalar if-then fuzzy rule, what you needed to provide is a crisp in, crisp out inference. There is no any fuzzy in, crisp out inferences at all. We don't need to do that because for scalar we always deal with the crisp in. We do not have a crisp. We do not have a fuzzy in. So it's very simple. We have crisp in, crisp out inferences. So you need to do that. This is the rule, right? So rule is simple. When you get a condition, well, excuse me, the condition should be a double array. Condition, I might call it conditions. Okay, so conditions is a double array, and then the get input value, well, we should change that to double array. So this public, this static function is shared by all the scalar if-then rule object, right? So once you get condition, you pass into it, and since user may specify the equation ID here, so you simply pass it, so you will get the inference result. But as I mentioned here, for the scalar if-then rule, we needed to return the filing strength too. So right here, if you take a close look here, in the instruction sheet, in the instruction file, I mentioned that this is the scalar if-then rule. So we have a get output value, right? So you need to implement the other function right here, and then we have antecedent parts, generic fuzzy set, we have integer conclusion, equation ID, and then we have crisp in, crisp out inference, crisp in, crisp out inferences. But we need to provide another parameter. This parameter is static, is simply for output purpose. So we add it right here. We add it. Double will return strings. We have a modifier out. It's a keyword specified on this parameter, which means that we need to determine this value. So once I specify out keyword on this parameter, you see a red clear came out because within current implementation, I did not specify any value of strength. So in here, you need to determine the strengths. So you need to find the strength, filing strengths came out, and then you will give value, right? So that's this double output value. So finally, you need to return, well, I might call it weighted result, weighted value, weighted result. Anyway, so initially it's 0. So return it. So you need to figure out how will you compute this one. So basically, you use that input condition to get the output value, and then you need to find out the filing strength, right? Filing strength, and we also you need to return filing strength back to the caller because scalar for the inference system, they let the user choose whether weighted averaged value will be returned or non-averaged value will be returned. So we need to return the filing strength for this rule back to the caller. Okay, so I think another one called Commodore if-then rule. For these parts are almost the same, but instead for For its Komodo if-then rule, the conclusion is a fuzzy set, but that should be the monotonic increase one. The inference will be a little bit different, right? For scalar, we need to compute from the equation, from the upper equation, get value. But for Komodo if-then rule, this CRISPR inference, it will use the firing strength to cut, to intersect with the monotonic increasing fuzzy set to get the output value. All right, so you need to carry out that by yourself. So what's left in this demo, it should be the, well, we needed to, so right now we have Mandani fuzzy inference system, if-then fuzzy rule. Basically, this fuzzy rule is for Mandani system. And we have a scalar if-then fuzzy rule. So you need to add new class. Scalar fuzzy system, right? Scalar fuzzy system. And also add class Komodo fuzzy system. So follow the Mandani fuzzy inference system implementation to complete these fuzzy systems. But not just the fuzzy system, we also need to add another class that should be Komodo if-then fuzzy rule. So in order to make the rule, the naming consistent, so we will change if-then rule file name, right? We'll call it Mandani if-then fuzzy rule. It's Komodo if-then fuzzy rule. Scalar if-then fuzzy rule. Okay. So we just usually will ask you to show the IntelliSense change all the name for you. Yes. So back to our if-then rule. So from now on, the class name has been changed into Mandani if-then rule. So make it clear. All right. So I think that should be the instruction for create Mandani, scalar, or Komodo for the inference system for assignment 6. So back to your main form. Probably what you need in your main form is that. So you have a Mandani system, right? So similarly, we kind of separate. You need to have a scalar fuzzy system, right? So I'm gonna call it scalar system. Komodo fuzzy system. All right. So just let us each time when user click on this button, or this button, you will create either a Mandani fuzzy inference system or scalar or Komodo, and then do the inference. So let's go back here. You see, this is bottom click. We create a Mandani system, right? So we ask Mandani do the CRISPR inferencing. So since the differentiation type has been property specified in the Mandani fuzzy system, so we don't need to do that. We don't need that. Yes, that's it. So once you instantiate a mandatory for this system, so probably by that time you may invoke that system to change the differentiation mode. You may change it into BOA, or LOM, whatever, if you like. Okay. So I think the inferencing functionality embedded within this button can be accomplished by this implementation right now. Okay, so what's left should be the file model safe and open. Okay, so for the inferencing, for the CRISPR in CRISPR out inference, we will end up here. So remember that you need to define mandatory fuzzy system, mandatory if-then rule, define scan-off fuzzy system, scan-off if-then rule, Sakamoto fuzzy system, Sakamoto if-then rule to help you accomplish the input-output response surface or line generation within this button. Okay, that's it. A few words for scan-on and Sakamoto fuzzy system. Well, since the inferencing method allows the user to specify whether an averaged output value will be returned or simply sum of weighted value will be returned. So, in scan-off fuzzy system and the Sakamoto fuzzy system, you should have a public property, right? Or we may call it output averaged, averaged. So it's a public property, so users can get and set, and then we kind of initialize it with true. So that means the inference result should be the weight averaged. So in this kind of inference, you need to correct the firing strength for each rule in order to get an average value. All right, so you should have this flag for scanner and the Sakamoto model. Let us go back to the Sakamoto if-then rule. During the inferences, we needed to find the intersection point or the firing strength in the membership function, right? So the output fuzzy set or Sakamoto rule should be the monotonic fuzzy set. So in that case, instead of given universe value, you find the membership value. Actually, that should be a given membership degree, and you need to find the corresponding universe value, right? So it's kind of like the inverse function calculation for the universe value. So as indicated in the instruction file, we will add a virtual function. Well, you can think about create that as a virtual property, but since we require a parameter, so it is better that we design that as a virtual function. So we take a firing strength, for example, right here, we call it degree, right? So intrinsically it is a degree. So once we get a degree, we try to find the universe value for it. So we kind of need to implement this function. So let us go back to our generic fuzzy set. In addition to the COA, BOA property, right? Last time we added here. So instead of that, we needed to add a public virtual function. So here we declare as a public virtual function double get universe value for a EGIE. So this function will be called in Tsukamoto rule, right? When the rule is asked to inferences in a condition. So once the final firing strength is calculated, this function will be called to get a corresponding universe value. So I call it degree. You can call it firing strength. It's okay. So it's a virtual function, right? So you need to implement the. So you what should you do? You basically loop through the range of universe, right? And to find the intersection value. So I'm not going to show you how to do it. You need to design the algorithm carefully in order to get the correct universe value for the intersection. So actually you need to carefully think about these cases. For example, we have a monotonic increase sigmoid function, right? But probably your firing strength is below to the first point. Probably your firing strength is right here, so your degree is right here. There is no any intersection, right? There is no any intersection point. So usually in that case, you should return 0, right? Otherwise, if we have intersection point, then it's okay. So that this universe will be returned. But in some cases, the lower parts will not have any intersection. So you need to simply return 0 if your firing strength is here. Similarly, if your firing strength is above this point, your firing strength is here. You need to return the maxima value, because our universe value has minima and maxima bound there. So you need to think about these cases. And for some monotonic fuzzy set, for example, this left shoulder, as you can see, if your firing strength is exactly 1.0, what kind of universe value will be returned? So the reasonable one should be the middle, right? So the middle value should be returned as the universe value, because this period they share the same members degree. So your firing strength is 1.0, and then there's no, these points are all the intersection point, right, with the members function. So in this case, the correct value returned should be the middle point. So that should be middle point here. So similarly, if your firing strength is 0, then you should check the first 0 point universe and the last point with the same members degree, and then return middle point of it back to the user. So I warned you that you need to carefully design the procedure in order to get a correct universe value for a given degree of firing strength. All right, this function definitely will be used for the will be called by Tsukamoto if-then rule. Okay. And for the user interface, right now, since we you need to add the option for the user to select whether it is a Mandarin or a scanner or Tsukamoto fuzzy set, right? So during the implementation, well, since right now we have a scanner conclusion equation, right? So we need to add a button, probably right here, and then which is similar to add fuzzy set, right? So if a user click on a universe, they can add a fuzzy set. But for a scanner model, if we use a click on the output universe, then the user can add the function, add the equation to output universe, right? So user can select it. So this button will add the ID to fuzzy set. So so I'm gonna call it maybe btn add output equation, and then subscribe it. So this one will be similar to add the fuzzy set. When user click on a universe, you can add a fuzzy set, right? But for the scanner fuzzy inversion system, once the user click on the output universe, user needed to add a function to its output universe, because the output universe, in output universe there is no any fuzzy set definer. We simply just provide a list of equation for output specification. So the face text we like to add equation. Okay, so we have y1 right here, right? So in that case, the code will be a little bit similar to your add a fuzzy set. So how can we add a fuzzy set? In add a fuzzy set, we terminate it. So we create a new fuzzy set, right? So we need to know ID. We have ID showed up, and then we create tree node. So similarly, we will create tree node. So let's copy it, and then let us go back to our main file. So this button, so we know right now the ID int equation ID will be equal what? That is user selected. User select this. This is the list box. So let me LSB EQUAT equations. So suppose you need to do the full proof checking on the condition. So the equation ID should be LSB equation selected index, right? Okay, so we will create a tree node. Tree node, it should have a name, right? So if there is a name, then I will call it properly equation ID. So it's tag, right? TN tag. We put this int there. We said TN tag. So tag is an object, right? But when our equation ID is int, so int can be regarded as an object, so there is no problem. Similar to that. So set tree node. Since we do not have tree node in our equation, so this line will not be available. Then the tree view, select the node at T and add this tree node, right? So we are not a fuzzy set, so that's it. And expand the O. Okay, so normally, if a user select a scanner fuzzy set, right, in order to create a scanner fuzzy set, so we will pop out this this tab page for user to specify output equation. So user, as usually, user can set up one-dimensional input, two-dimensional input. User can here add a Gaussian function, add a triangular function. For antecedent 1, antecedent 2, user can input universe 2 and add a Gaussian function set, and let's modify what you said, right? But for the output, it is not allowed to. So for the output, we need to create universe first. Create output universe, and only one output universe can be specified. So within this output universe, we need to specify equation ID. Right? So we need to add it. So suppose this scanner model have more than one equation show. So user can select this one and then add equation. All right, so you will see equation 0. Come on. So since right now I just have one, so if a user click on it, so that is the scanner model, scanner fuzzy model. Input is the fuzzy set. Output is the equation, but right now it's the equation ID, right? So probably it is not just that. Maybe once you set up tree node, it's a name, but you can specify the text. Text equal what? Equal the LSB equations items equation ID. So make it much more clear. We kind of set the face text of this tree node. But since it's an object, right? So we will add to string. Text should be a string. Okay. So let us see what it look like. So user, if user want to create a scanner model, so specify output universe. On the output universe, you will hide this button. The output universe should not let the user add the fuzzy set to output universe, but instead user will specify equation, right? So if I click on this guy, click this add equation, this will be added to this tree node. So tree node indicates that this is the zeros equation. The content of the equation is here, 0.1x plus 64. Okay, so this is the cases for the scanner for the inverter system, right? So as usually, user can add the fuzzy set here, add the fuzzy set again to to input universe. It's better, right? The length is not expanded, so it's poor. This tree view, the user interface is poor. Okay, so when user construct scanner if then, how can they do that? So similarly, if user add a rule, user kind of select Gaussian as the condition part. What's wrong? I'm sorry, I did not follow the rule, right? So universe 1 actually is an output universe, not input universe. So it's kind of confusing. Probably you should arrange. So user might arbitrarily define the universe in different kind of order, but we prefer probably in the front part should be input. So right now it's kind of confusing, but it's okay. Universe 2 put in here. It's antecedent parts, antecedent 1, and it should be antecedent 2. How about the conclusion? Conclusion should be equation, right? So similarly, user click on this guy, say, well, this should be the output equation. Click on this place. Click on this place. Nothing happened, right? So that is because we kind of suppose that should be the fuzzy set, right? So I think in quick event you need to do some changing. Okay. So back to here. Say quick. So normally we suppose that the quick the tree node should be the fuzzy set, right? So generic fuzzy set take as generic fuzzy set, right? So and then target is right here. So we set the cell value into target. Okay. So tag is a generic fuzzy set. But right now, for scanner model, the tag might be an integer, right? So how can we do that? I think we can easily bypass that by target. What is this? So probably we can check that. If the treat node tag, so we kind of separately deal with that. So if tribute selected node tag is integer, and we know that that is integer. So if it is integer, it's very simple. Well, how can we do that? So we will set the value. So we set the value. So the value should be object, right? So set the value and then set the value to our integer. So that should be the tag. And return. Okay. So later on, I mean, if you, in your main phone, if you want to construct a scanner, if it's a rule, you pick it up from the cell. It's actually an int. So an ID tag is int. So you know the equation ID. So you can assign that int to scanner if it's a rule. Okay, so that is the cheapest way, easiest we can assign that. So again, if we are creating a scanner model of a universe, so within this antecedent, we add a Gaussian fuzzy set, add a bell. Second, we add a sigmoid, add a bell function. So this time, if user click on this output universe, you should hide this button and then pop out this equation list for the user to specify output equation. So up to this moment, if the user select this equation 0 then put it there, so we have output equation displayed under this output universe. And when user try to specify the rule, so user add a rule, right? Add a rule, and then user click on this fuzzy set. It's okay. The second fuzzy set sigmoid, and then it came to the output equation selection. So user select this guy, click on this cell. So we came to this spot. So right now tag is actually an integer 0. So simply execute this line and then return it. So you see output universe is 0, which means that equation 0. So within this cell, the value is an object, right? But actually it's an integer, it's an equation ID. But for the antecedent parts, oops, sorry about that, made a mistake. What's wrong here? Oops, we'll replace it. So it's kind of no problem. Okay. So this way you can specify the output equation ID here. Okay, I think that's all. I mean, for the for the inference system modeling. So you need to do the detailed implementation by yourself. Never mind, you just finish the mundane fuzzy set system. I mean, completely. After that, you can do the similar work for the scanner and the Tsukamoto model. All right, that's it.